Now we were looking at future value of $100 at 10% for 5 years. So we might have future value there, future value interest factor, which is equals to 1 plus 0.1 to the power 5. Hence, our future value would be equals to the invested amount, 100 multiplied by that one. Or we can actually get this from tables. Now our table is 5 years, 10%, which is 1.6105. 1.6105. Then we put it there, just paste it there. If we multiply, you see those numbers are kind of the same. Multiply 100 multiplied by that one, we get that answer. See, that is what we get. That's future value of a lump sum. So we have solved for future value there. Now let's look at a future value of a cash flow stream. When we're talking about a cash flow stream, we can talk of different cash flow streams. $300, $200, 300 in the first year, 200 in the second year, 400 in the fourth year. You are receiving those amounts. How much will they be in year 5? That's future value of a cash flow stream. Okay, so how we get the future value of a cash flow stream is you add the compounded cash flows as shown in that formula, where we are saying, in other words, we are pushing these to a particular future date. Future value in period n would be equals to the summation of cash flow t multiplied by 1 plus r to the power n minus t. You would see where that n minus t works. Now let's have an example so that you see how it works. Consider an investment which promises to pay $100 1 year from now, $300 2 years from now, and $500 3 years from now, then $1,000 4 years from now. How much will be the future value of the cash flow streams at the end of year 4, given that the interest rate is 10%? Right, let's do what we said we have to do. We want to see the future value at the end of 4 years. So let's draw a timeline which shows what we are going to receive and when. Now, interest rate is 10% there. So in year 1, we receive $100, year 2, 300, year 3, 500, and then the 1,000 in year 4. So how much is this worth at the end of year 4? You'd note that in year 4, it is worth 1,000 because how much is it worth in year 4? 1,000 is already in year 4. So 1,000 is worth 1,000 in year 4. But those other ones now, for instance, how much will 500 be in year 4? Let's check. By how many years are we pushing this 500 so that it gets to year 4? We are pushing it 1 period. So if it's 1 period, 500 and it's 1 period, I want you to see something here. So the cash flow in year 4 would be how much? Would be 500. So on CF there, we put 500, 1 plus I, 1 plus 0.1 to the power n minus t. Now this is cash flow in year t, which is cash flow in year 3. So t there is 3. Then what is our future value period? What is the last year in which cash flow occurs? What is the last year where we are saying, let's push this to year whatever? It's year 4. So n there is equals to 4. So 4 minus 1 would give us 1. 4 minus 3 would give us 1. So we are pushing the 500 by 1 period there. We are compounding it by 1 period. 300, 4 minus 2, 2. So we can say we are moving it 2 times from year 2 to 3, 3 to 4. It becomes, you apply that in that formula and see. So that's the timeline. So we now want to see what these amounts would be equal to in year 4. Now in year 4, if we then apply the formula that we can apply there is for each year, it's CFT multiplied by 1 plus R to the power n minus T for each year. So let's see. That would be the formula. Okay. 100, 1.1 to the power 4 minus 1. We're pushing it 3 times. 300 multiplied by 1.1 to the power 4 minus 2. And then 1000 multiplied by 1.1 to the power 4 minus 4. Then we press our calculator. We check from our calculator what we get from those figures. Or we might check from our tables if we are allowed to use tables, or if the question, if the rates there are in sync with what we have in our tables. 10%, for instance, 10% for 4 years. What is the FV? 10% for 3 years, 10% for 2 years. We apply the requisite future value interest factors for those payments, and our answer comes to that. Okay? Our answer comes to that. Now, if you are making use of a financial calculator to find that, make sure to use the appropriate interest rate, time period, and present value for each of the 4 cash flows. To illustrate, for the first cash flow, you should enter the PV is 100, N is equals to 3, I is equals to 10, payment is equals to 0, FV is equals to what? Now the FV will just come out. For the second payment, PV is equals to, what is the second payment? PV is equals to 300. What else do you need to put there? N is equals to 2. I is equals to 10. PMT 0. FV is equals to what? They will just come out like that. Okay? So you can check using your financial calculator as well to see what you have there. Now, let's try and find a solution to that one. Find the future value at the end of year 4 of the following cash flow stream given that interest rate is 10%. Find the value at the end of year 4 of the following cash flow streams given that interest rate is 10%. So simple. You just apply that formula. Future value, as we look at it from period 4, would be like that. Okay, our answer is 895.10. But you can also prove this on your own. Don't just listen to these things. Just prove on your own. Because if you try and prove them, for instance, in the exam, you might not like it, especially if you're just following and liking the videos. Okay? Now, let's look at annuities. When we're talking about an annuity, we're talking about a cash flow stream in which the cash flows are all equal and occur at regular intervals. For instance, monthly, yearly, or biannually, etc. You can be receiving $100 per quarter. Every 3 months, you receive $100. Okay? That's an annuity. You are receiving $100. You are receiving $200, whatever. If the amounts are equal and you are receiving them at regular or equal intervals. Now, to be considered an annuity, to be considered as an annuity, the following conditions must be present. The periodic payment must be equal in amount. The time period between payments should be constant, should be equal. The interest rate per year remains constant. The interest is compounded at the end of each time period. So that is what qualifies an amount or stream of cash flows as an annuity. Let's look at types of annuities. Annuities, we have what we call ordinary annuities, one where payments are made at the end of each period. So if I'm receiving rent, no, rent is received at the beginning of the month before you stay, is it? If I'm receiving a salary at the end of each month and the salary is constant, that is an ordinary annuity. Okay? An ordinary annuity is one where the payments are made at the end of each period. So if you expect to work for 45 years or for 10 years, you can check what is your value. Okay? How much are you worth in your current job? By just finding the present value of the ordinary annuity. Now, an annuity due is one where the payments are made at the beginning of each period, like when you're paying for rent. Ideally, school fees or university tuition fees must be an annuity due. A deferred annuity is one where the payments do not commence until period of times have elapsed. That's a deferred annuity. You can start receiving it 10 years from now or paying 10 years from now. A perpetuity is an annuity which can be received or paid forever up to infinity. It can be payments continue indefinitely. So under a perpetuity, n is equals to infinity. Okay? N is equals to forever. Now, let's look at an ordinary annuity. Let's look at the future value of an ordinary annuity. How do we calculate the future value of an ordinary annuity? For calculating the future value of an ordinary annuity, you can actually find it by that. Future value of an ordinary annuity is equals to the cash flows, or we normally put an A there, cash flows, 1 plus R to the power n minus 1 all over R. So 1 plus R to the power n minus 1 all over R. That is what we call the future value interest factor of an annuity. The future value interest factor of an annuity. Okay? Now let's check in our tables. In our tables there, we've got present value tables. Let's check. We've got future value interest factor of an annuity. Now that is what we are talking about. Future value interest factor of an annuity. Now that's the formula similar to the one we have in our slides there. Now, if you are receiving an annuity for 5 years and the interest rate is 9%, let's assume you are receiving $100 per year for 5 years. What would that $5 be in 5 years? What would that $5 be in 5 years? You multiply by 5.9847 in the tables there, as shown in the tables there, and you get a future value of that annuity. Okay? So using tables, we just say the payment multiplied by the future value interest factor of that annuity of any periods at R. Okay? You can get that one. Now, future value of an annuity is derived as shown there. Is derived. Future value of an annuity at N is equals to annuity multiplied by that one. You see, I want you to follow that and come up with that formula and see where that thing is coming from. So that's the future value of an annuity. That's the formula. It's the same as the one we have on top there. So, but I prefer that we use A in our calculation so that we show that the cash flow is in actual fact an annuity. Okay, that's the future value of an annuity. What amount will accumulate if we deposit 5,000 at the end of each year for the next 5 years? What amount will accumulate? How much will we have at the end of 5 years? How much will it be at the end of 5 years? So deposit at the end of the first year, if it's an ordinary annuity, at the end of the first year, 5,000. Okay, at the beginning of the year, we deposit 0. You see, at the end of year 1, we deposit 5,000. Year 2, we deposit 5,000. Year 3, we deposit 5,000. Do you see that we've got a stream of 5,000s that we have there? Now, that stream of 5,000s which we have there, we are compounding them. We are compounding them. We are compounding them. As we are compounding them, that's the answer. We accumulated to 28,185.46. But what if we do this? We have our annuity. Annuity, we are depositing 5,000. And what is our N? Our N is equals to 5. What is our I? Our I, is it 10%? Our I is 6%. 6%. What else do we need there? N5P there, that one. Okay. What is our future value interest factor of an annuity? What is our future value interest factor of an annuity? For 5 years, 6% at 5 years. Future value 6% for 5 years. Is that one? Is that correct? So we have that one. So our future value would be equals to the 5,000 multiplied by the future value interest factor of that 28,185.5. 28,185.5. Yes. So that's the answer. That's the accumulated amount at the end of the 5 years there. Let's assume maybe the question is saying 6.56% is the interest rate, which means we might not get this in our tables. So we might need to apply the formula there. What is the formula? You must just know what the formula is. You must be able to use it. It's 1 plus r to the power n. Now our r is 6%. So we want it to be in the same line as that one. Is equals to open bracket 1 plus r. This is our r to the power n. Our n is 5. All this divided by I. Yes, you see now. Now let's check if we use our formula. It would be that one multiplied by the 5,000. Then we get 28,185.46. That's our future value of that annuity. Okay, that's future value of an ordinary annuity. That's how we find it there. Okay. Step-by-step calculation shown there. Now let's look at an annuity due. Annuity due. Now we said the payments are being received at the beginning. So which means the first payment, if it's in that question we are looking at, it's happening at the beginning of period 0. So it's a form of annuity where periodic receipts or payments are made at the beginning of the period, and one period of annuity term remains after the last payment. Okay. So future value of an ordinary annuity, of an annuity due, is equals to future value of an ordinary annuity multiplied by 1 plus I. Check that formula there. You would see that annuity due is the cash flow multiplied by this formula. The first formula you are seeing there is the formula for ordinary annuity multiplied by 1 plus I. So the future value interest factor of an annuity due is the future value. In fact, the future value interest factor of an annuity due is equals to the future value interest factor of an ordinary annuity multiplied by 1 plus I. Okay? You just multiply by 1 plus I to the factor of the ordinary annuity. Okay? So that's that. So future value of an annuity due is equals to the future value of an ordinary annuity multiplied by 1 plus I. I think I don't need to emphasize more there. Okay? So I want you to prove or show that the future value of an annuity due, assuming that the payments, the 5,000, are now being received at the beginning of the year, show that it's 29,876.59. Show that. it is that. 10 marks if you want marks. Okay? Show that it is that. Now, what amount will accumulate if we deposit 1,000 at the beginning of each year for the next 5 years? Assume an interest of 5% compounded annually. What amount will accumulate there? How much will accumulate? Now, this is being deposited at the beginning of the year. So how much will accumulate? Okay? How much will accumulate? I want you to work out that one on your own. Let's look at a deferred annuity. Let's look at a deferred annuity. What is a deferred? Now, when the amount of annuity remains on deposit for a number of periods beyond the final payment, the arrangement is known as a deferred annuity. You guys are very much conversant with deferring your studies. It's the same concept here. Okay? When the amount of an ordinary annuity continues to earn interest for an additional 1 year period with an annuity due situation, when the amount of an ordinary annuity continues to earn interest for more than 1 additional period, we have a deferred annuity situation. Maybe we might understand this using a formula. Now, how do we find future value of a deferred annuity? Now, we use that simple equation or simple formula shown there. The future value of a deferred annuity is that one, P multiplied by whatever you are seeing there, where a CF annuity cash flow and SCF is the single cash flow that you get somewhere there. So that is the formula for what? For deferred annuity. Okay. I know you understand this from an example. What amount will accumulate if we deposit 5,000 at the beginning of each year for the next 5 years and wait to get the amount for additional 2 years? Assume an interest of 6% compounded annually. What amount will accumulate if we deposit 5,000 at the beginning of each year for the next 5 years and wait to get the amount for the additional 2 years? Okay, what amount given those things there? So we are going to have these funds held for an additional 2 years when we are no longer contributing. Okay, what is the present value of that? What is the amount accumulated? What is the future value of such a stream of payments? Now, that is how we work it out. Simple as that. So you are following. You guys are bright. That's how we calculate the future value of that annuity due. Okay, so our answer there would be 31,669. That's the future value of that annuity. Okay. I can show you another method to work this one out. Okay. So here we were just looking at future value, but you must know that you might be given a scenario where you might need to calculate interest, where you might need to find N, where you might need to find the FV or the PV or the annuity. You must be able to play around with it. This is Form 3 stuff. You must be able to play around with the formulas there so that you get what you need there. I think that's that with future value. In our next lecture or in our next recording, I would look at the present value of everything. Thank you so much.